today's class we're going to study the NaOH and COCl2. Okay, and might be baking soda. These two we'll be going to study in the next class. Okay, so first of all, if I'm talking, what is NaOH? NaOH is caustic soda. Don't write anything. Okay, just a minute. Let me talk to the team. That where are the other students? Just a minute. Okay. So what I'm saying here is that okay, you need to understood one thing that NaOH is caustic soda that we studied here. Okay, so what is NaOH? NaOH is caustic soda. Caustic soda. Okay, it is caustic soda. Caustic soda. And how it is prepared? If I talk about the caustic soda, it is a strong base. Strong base, and since it is water
Sir,
soluble, yeah,
what's caustic?
caustic is the common name for caustic is a name for uh, sodium hydroxide. Okay, caustic soda. So if you ask me the name of bleaching, what is bleaching? So what should be the name of bleaching? Bleaching means bleaching. Okay. So that's caustic soda is the name for NaOH. That is water soluble base, strong base, and it is since it is water soluble. That's why it is also called alkali. Also called alkali. Don't write anything. Okay, just when I ask you to write, then you have to write. It is also called alkali. And how it is prepared? How can be prepared NaOH? So NaOH can be prepared uh, when we pass. If we are talking about that, how can NaOH caustic soda can be prepared? The caustic soda can be prepared when we have NaCl plus water, and we pass electricity to it. We pass electricity to it. Okay, so on passing electricity to this one, we'll get Na, uh, NaOH plus Cl2 chlorine gas plus hydrogen gas. NaOH is obtained near cathode. Okay, Cl2, since Cl is negatively charged, so it will be obtained at anode. At anode. Why? Because anode is positively charged. It is positively charged. So since negative goes to positive, that's why Cl minus ion will goes to positive and will form Cl2. Okay, and hydrogen. This will be at anode, and this will be obtained at cathode. Why at cathode? Because H plus ions will be attracted towards the negatively charged rod. That is negatively charged rod. That is called cathode. Because positive attract negative, negative attract positive. Okay, so this is the way that how if we have aqueous, allow NaCl in water, that is called brine. Brine. Okay, so please note it down this one about the NaOH caustic soda that is here on the screen. Please note it down. And everybody, please turn on your camera. भैया turn on your camera. So how caustic soda is prepared? When we have NaOH and prepared by passing electricity to NaOH. We done? This process is known as chloralkali process. Stop writing this, listen to me. Uh, what I'm saying, this process is known as chloralkali process. Why it is known as chloralkali process? Because in this process, NaOH along with Cl2 and plus hydrogen gas. So this NaOH is known as alkali because it is water soluble base. Any base which can be water dissolvable or water soluble, this is known as alkali. So NaOH is an alkali, KOH is an alkali. So since NaOH is forming here, and chlorine gas is also very useful. So chlorine gas is also formed here. So that's why its process is known as chlor for chlorine, okay, and alkali for NaOH, for NaOH. So this process is known as chloralkali process. You understood? Understood? Yes or no?
So can you explain it again?
Yeah, why not? I'm saying here is that NaOH is a base, which is a water soluble base. NaOH is water soluble base, and Cl2 is if I'm talking about chlorine gas is chlor, which stands for chlorine. So since during the preparation, when we have brine is a solution of NaCl and water. So when this solution of is mixed and we have NaOH plus Cl2 plus H2. So this NaOH is known as we called it strong base. And since it is water soluble, it is known as alkali. This is known as chlorine. Okay, it's chlorine gas. So since chlorine gas and alkali, water soluble base is formed when we do the electrolysis of brine, which is a mixture of NaCl and water. So when we do this one, so we'll say that this whole process is known as chloralkali process. Okay, because a base and a chlorine gas, alkali, water soluble base and alkali is formed here. Okay, so do this one first.
Sir,
Yes,
so do we have to draw this diagram also?
no, no need to draw the diagram. Harshit, when you turn on your mic, okay, and I speak something, then my voice is coming back to me. Why it is so? Are you
I don't know, sir, why it is.
Sumaya, are you there in the class? Sumaya, are you there? Sumaya, done? Note it fast. So this process is known as chloralkali process due to the formation of chlorine gas and NaOH and alkali. When you're done up to here, then let me know. You done? Noted? Did fast.
Done.
Done? Aisha, you also done? Okay. So now if I'm saying here that how these reactions work actually, when we have Na positive ion, let me explain. This is water here inside this water, and they are the two electrodes. Okay. And when we have aqueous solution of NaOH, NaCl, so we will have Na positive and Cl minus ion, Na positive and Cl minus, Na positive and Cl minus, Na positive and Cl minus. Okay, like this way. So, and we also have the water because it is in the water, so it is also going to have H positive and OH minus, H positive and OH minus, H positive and OH minus. Okay. So it is going to have OH minus. So what happened here is that you know that if this rod is positively charged anode and this rod is negatively charged cathode, okay, this is anode and this one is cathode. Then what we are going to do here is that anode, the Cl minus ion will goes towards anode. The 2 Cl minus ion will go towards the anode, okay, and they will lose their 2 electrons. Means at anode, what is going to happen? At anode, the 2 Cl minus ion will goes and they will lose their 2 electron and will form chlorine gas. What happens here? Plus 2 electrons. Like Cl minus ion means chlorine with chlorine have 7 electron in its outermost shell. 2, 287, 17 atomic number. But when it gains an extra electron, then it acquire a minus charge and it is going to have now 2,8 electronic configuration, 2,88. Now another Cl minus ion also. It is also minus. So when they lose one of its electron, like they lose one of its electron, this electron will be loosened, this electron will be loosened, and they will now combine together. 6, 7. They will form like sharing bond here, and they will lose one electron, and they will form 287 and share one electron. So they will lose one of its electron. This is known as means they will lose one of two, means one electron will be loosened and they will form chlorine gas. So chlorine gas is formed here. Now at anode, what at cathode, what is going to happen? At cathode, you will see that we have Na, sorry, H plus ion. Okay, now you can say that why Na is not going to become Na solid. We have two type of plus ions, Na positive and H positive. So why Na is going? So Na is good electron donator, not electron gainer. Na is stable. It will not wants its back. Na positive has 2,8 electron configuration. When it loses one of its electron, it become Na positive and now it has 2, 8. So it is already stable. So it will not want to gain the electron to become Na solid. So what it will remain as Na positive. So the H positive ion will attract one of its electron, the 2H positive ions from at means what this is going to happen at cathode. At cathode means negatively charged rod. So these two negative electrons that was produced here, these 2 electrons will be gained by 2H plus ion, one each. We change the pen. This is not working. Stop. So the two H plus ions, the two H plus ions, okay, will go and will gain these two electrons, one each. Like this is H plus ion, like this is another H plus ion. H plus ions means when the hydrogen loses one of its electron, they become H plus ion. To become hydrogen gas, they require one electron each. So this one electron will be gained by these two H plus ions. Okay, and they will form hydrogen gas, H2 gas. So this is going to happen at, and this Na positive ion and this OH minus ion, they will combine together and they will form NaOH. Understood? Yes or no? How hydrogen gas is forming at cathode, and why how chlorine gas is forming at anode electron donation is taking place. And Cl minus ion will donate their electron and will form chlorine gas. So in order to form chlorine gas, a chloride ion must lose one of its electron, and then they have to form a covalent bond by sharing one electron. So like this way, here they need to share one electron. Again, I'm going to explain you that this is chlorine at 1, 2, 3, 4, 5, 6, 7 electron in the outermost shell. They both has loosened one electron. Okay, if it is Cl minus ion, it will behave like this. They both are Cl minus because they have one extra electron. Actually, they have 7 electron in their outer mission. Now they are having to become Cl atom, they have to lose one of its electron, and now the charge will be zero, and they will become like this. So this is the chlorine gas. So note it down here. Note it down to here. We have to take always a concentrated sulfuric acid, sorry, concentrated solution for this one. If we take the dilute solution, then instead of chlorine gas, oxygen gas will be produced, and simple. Okay. Noted.
No,
Noted first. So you done this one?
Yes, sir.
So now you understood that. Let me explain you the concept here. That we have a reactivity series now, like sodium, potassium, sodium, calcium, magnesium, like this way. This reactivity series is based on what? It is based on the element which will lose the electron first. Among this element, if I am having potassium, potassium is the top which can lose the electron at first. Then sodium, then calcium, then magnesium, then aluminum, then zinc, then iron, then tin, then lead, then hydrogen, then copper, then silver, then okay, and so on. Like it is keep on going for the negative. Then we have F minus, then sulfate ion, then nitrate ion, then chloride ion, then bromide ion, then OH ion. Okay. So if I ask you that we are having two negatively charged ion, one is Cl minus ion, another one is OH minus ion. So OH minus ion do not donate the electron first. Only the Cl minus ion is going to donate. Like for example, you can understood like this way. Like for example, we have the two substance whose one of the boiling point is 100 degree, another one boiling point is 60 degree. So when you start heating, when the temperature reaches 60 degree, the compound or the substance that has 60 degree boiling point will start evaporating or boiling. Okay, the other 100 degree temperature will not reach unless and until whole 60 degree substance is going to get evaporated. Okay, same thing happen here. Unless and until this you see that this is the chloride ion here and OH minus ion here. So in term of losing, chloride ion come first, then OH minus ion. So the chloride ion will lose electron first, then OH minus ion. Okay, got it? Got it?
Yes, sir.
Now, what I'm saying here is that, what I'm saying here is that, like similarly, if I ask you that we are just having the potassium at the first for losing the electron. So this will be reverse in terms of gaining the electron. Means if we need to give the electron, the potassium will be the last to gain the electron. Are you getting a point? Potassium will be the last to gain the electron. That's why we have Na positive ion and H plus ion. So in terms of gaining, like for example, like you see here, sodium was, I'm saying that we have the two positively charged ion to gain the electron. Sodium can also gain the electron at cathode, and H plus ion can also get the electron. But why H plus ion is going to form hydrogen gas? Why sodium is not gaining the electron? Because you see here, hydrogen comes here. So in terms of gaining electron, hydrogen is first, then sodium. Potassium is the last. In terms of losing, potassium will be at the top. But in terms of gaining, potassium will be last. This series will reverse in terms of gaining. It will be at the first to gain, and this will be the last to gain. So here we will see that hydrogen come first to gain the electron. Got it? And in terms of losing, this series is like this. In terms of losing, this series is like this, like this. Just keep on coming. Understood what I'm saying here? Okay. So note it down, please. You noted? Yeah, you have noted this one. So that's why chlorine gas is formed here. And because chlorine is the first to lose the electron, then OH minus ion, and hydrogen gas is formed, not the sodium solid is forming. Because sodium, when gain one electron, it will also form sodium solid. But it is not forming the sodium solid. It will remain as Na positive. Why? Because we have H plus ions here, and H plus ions is first to gain the electron, then sodium. Sodium is first to lose, not to gain. Okay. So here, noted down the physical properties of NaOH. White translucent melting point at 591 Kelvin, readily soluble in water, deliquescent. When prolonged exposed to air, it reaches with atmospheric carbon dioxide and form NaOH, the CO. Note it down, please, each and everything that is being written here. This is very simple, nothing to explain.
So what's the third point?
What is where the third point? Acha, third point, deliquescent. Deliquescent. What do you mean by deliquescent? Deliquescent means when it is capped in open air, it will absorb the moisture from the atmosphere. That is called deliquescent. Deliquescent. QUE. Deliquescent. Harshit, you writing?
Yes, sir.
Become fast.
So what's written after atmospheric CO2 and
Atmospheric CO2. Yeah. When it react with the when prolonged exposed to air, it will react with atmospheric CO2 and form sodium carbonate. Sodium carbonate. Note it down from here. Form sodium carbonate. Done? Done? Yes or no? Note it fast. Done?
Yes, sir.
Harshit, note it fast.
Done, sir.
Next is bleaching powder. Next is bleaching powder. Bleaching powder is very simple. Okay. Let you have calcium hydroxide. This is calcium hydroxide. Its name is calcium. Its name is calcium hydroxide. Then the common name is calcium hydroxide. Okay. Means what is actually bleaching powder? First, let me explain you. Bleaching powder is calcium oxychloride, which is called calcium oxychloride, or we can say it hypochlorite, calcium hypochlorite, calcium hypochlorite, hypochlorite. So sometime in 1 marks, this question may be asked that what is the chemical name of bleaching powder? So this chemical name is calcium oxychloride or calcium hypochlorite. Understood? Second questions that how it is prepared. How can you prepare? So you know that this is calcium hydroxide, which is called slag lime. It's called slag lime. Okay, and how slag lime is prepared? Can anybody tell me that how slag lime is prepared? How slag lime is prepared? Can you tell me how slag lime is prepared? When we have calcium oxide, when it react with water, it will form calcium hydroxide. Okay, so this is calcium hydroxide, which is called slag lime. It is highly exothermic reaction. Okay, now if I ask you that this is calcium hydroxide, this is called slag lime, and it's watery area. Like for example, we make curd, okay, at home. How many of you have made the curd at home? Everyone? No, you have not made the curd at home. Like for example, sometimes we have milk, okay, we added a few amount of curd to that milky. Okay, so you will see that this the next day the curd will be formed. Okay, and you will have some watery part, and sometimes very some part is very dense white, okay, which is curd, and some watery substance. Okay, so similarly, when this calcium oxide react with water, it form calcium oxide, which is a dense. If it is dense like curd, okay, it is known as slag lime. It is known as slag lime. But it's watery part, which is transparent, or we can say translucent, and little bit milky, or very light milky color, like the curd water. Okay. How many of you have seen the milk got rotten when you do not boil it for long? You have seen that one, the same thing. When if you boil that milk, the watery area will become separated, and the white milk will come separated. Okay, so same thing happens here in this also. When the dense creamy layer like form, that is called slag lime, which is thick like cream like structure, and there is some water like structure that is also having the same formula. It is a dilute solution, but it is called lime water. It is called lime water. Both have same formula. Okay, both have same formula. So if I'm having here, this is calcium oxide. Okay, calcium hydroxide. When chlorine gas is passed through it, calcium hydroxide. When we pass chlorine gas to it, it will give you calcium oxychloride plus water. Calcium oxychloride plus water. Understood? Understood? This is called calcium
Yes, sir.
oxychloride. Calcium oxychloride.
So
So
then slake line same as cheese then?
yeah, you can say that. Slag lime is same as cheese. So this is very dense part. Okay. So when we pass chlorine gas to that creamy like substance, okay, it is not like the cheese, which is very hard. You touch it to the cheese, your finger will remain, means do not stick. But if you have that, if you touch these slag lines, your finger will get wrapped over it. Okay, and it will get wrapped over your finger. It is just like a cream. Okay. So when you pass chlorine gas to this, this is like this is a process like this. you pass the slag line here and the okay, and you pass the chlorine gas from here. So it will goes like this upward. It will keep on going like this upward, and these rotator blades are moving like this. Okay, and these are the blades that are revolving and they are mixing. And waste gas that do not combine with the slag line, that chlorine gas is collected from here. Okay, and we keep on going, and the bleaching powder is obtained from here. So we have, how can we prepare the bleaching powder? When we pass chlorine gas to this one, it will give you CaCl2 plus 1. Okay, and this process is known as Hazen-Clever process, Hazen-Clever part. Okay, the formation of like the formation of bleaching, sorry, caustic soda was chloralkali process. Here, the formation of this calcium oxychloride or bleaching powder is known as Hazen-Clever process. Okay, you understood? So how it is prepared, and you understood the difference between lime water and slag lime? Yes or no?
Yes, sir.
Okay, and lime water is watery-like substance, which is a dilute solution of
Is it
slag lime.
lactic acid?
No, it is not lactic acid. It is a base. How it is? How can it be lactic acid? Okay, so here we have it down.
Sir,
Yes,
sir, actually, I want to say, have you seen my paper? Science question.
your question paper.
Yes, sir. Actually, I have a doubt. I have also asked you last week.
Okay, okay. What now?
Sir, actually, a question in the chemistry was outside. So, sir, could you please give us like more question about this? Because, sir, I don't know where to practice like more this question. Maybe it is out of syllabus or not.
Okay, let me check your paper.
Sir, if you see that there was a very big portion of a about the acid base salt.
Big question actually. We have not studied it salt, then how can it be?
No, sir, only just acid base.
Let me check. Let me talk to the thing. I have sent it. There. She will send me. Okay, now you done this one? Done? Yes or no? So bleaching powder, noted fast. Noted fast.
So done.
You also? You done? Aisha? Hmm? Do it first. Done? Aisha done? And Harshit, you also?
Done.
Next, if I'm talking about the properties, it is a yellowish compound. Mute yourself, Harshit. The voice is coming back. So it is a yellowish powder, give a strong smell of chlorine. Okay. And we can say that uh, it when you kept it in open air, when you kept it bleaching powder in open air, then it will react with the atmospheric carbon dioxide. So atmospheric carbon dioxide in the previous was also. If you kept the NOH, it will also react with the atmospheric carbon dioxide and form Na2CO3. Similarly, if you have if you have CaOCl2, if you kept it in open air, it will gives you calcium carbonate. These three and this two will react. It will give you CaCO3 plus chlorine gas will be eliminated out. So we'll simply say here that the elimination of chlorine gas is only possible when you cap the bleaching powder in open air. So bleaching powder is should be capped in airtight container. The question comes in examination that why should bleaching powder be capped in open air? Because if you capped it in open air, sorry, why bleaching powder should be kept in airtight container? So the simple reason that because if you kept this one in open air, then it will react with the atmospheric carbon dioxide and form CaOCl, calcium carbonate. Okay, you understood? Yes or no?
Yes.
Yes, sir.
So note it down this one. Yellowish powder give a strong smell of chlorine. So if the question comes for this one that a compound X which has a strong smell of chlorine. So if strong smell of chlorine, when it is said strong smell of chlorine, that you must keep in mind it is we are talking about the bleaching powder. Okay. So bleaching powder uh, gives very strong smell of chlorine. Okay, no. Note up to here. Done? Noted?
Yes, sir.
So, you also mark. Done? Done, Mahan? Noted fast.
Done, sir.
Done? Okay. Note this one. Aram, turn on your camera. It is a very strong disinfectant. This is very important property of bleaching powder, that bleaching powder is used as a disinfectant. Means it is used mainly for killing germs. Okay? It is used for killing germs. Okay, fast. Hello, Sarah. Anna. Anna, how are you? Is I'm audible?
Yes, sir.
Okay, just the students are writing that. So just wait for 1 or 2 minutes. Okay. Let me
Okay,
share
sir.
this.
Done, sir.
So anyone still writing? It is a strong oxidizing agent used for manufacturing chemicals. It is employed for making rolls and measuring cable. It is chiefly used for bleaching and cottons and linen textiles. For this strong disinfectant is used for killing germs. Okay. So the most importantly that is being used is this disinfectant property. And the second one is that it has a strong smell of chlorine. So this type of question is going to come in an examination. Okay. Got it? So that's all for today. We'll meet you in the next class. Thanks for coming. So yeah. So Aisha and yes, everyone, Sarah, all the other students, and please everybody turn on your camera. Turn on your camera, everyone. They're not visible to me. Turn on your camera, everyone. Aram, Nan, Saad, Rafe, Sarah, everyone. Please turn on your camera. Okay. So what we are studying here today, Saad, you are not visible to me. You are black. So in the previous class, we have discussed the questions. Okay. We need, I have given you some practice questions to practice. Today, we shall be moving further towards I think we have done carbonates compound, homogeneous and heterogeneous mixtures we have done. Sorry, carbonates compound, not absolute. Mixtures and its compound. Uh, and we have done homogeneous and heterogeneous mixtures. We were on the concentration terms. Let's practice some more questions on concentration terms. Your camera is on. The screen is visible to you all. So we are discussing the concentration terms. And in the previous class, we have discussed, we were on the questions, okay? Mass by mass percentage, okay? So there are different types of questions that we have and different types of mass by mass percentage. So let me revise one more time that is very important. First one is mass by mass percentage. This definition we have written that when X gram of solute dissolve in 100 gram of solvent, it is mass of solute upon mass of solution into 100. Second is mass by volume percentage. That is mass of solute. If it is mass at the first, so we will use mass, and volume at the second, so it will be volume of solution. Volume of solution. Okay, if it is in gram, then it should be in ml into 100. Okay, and the third one is volume by volume percentage. That is very simple. Like this is mass by mass, so the volume of solute divided by volume of solution into 100. Note it down, everyone. Note it down. Saad, Anam, Arhan, do you need means are you simply turning your camera on, or should I start giving you some dart? बिना डांट खाए नहीं माना.
Camera on in a minute.
Arhan, are you there in the class? Arhan? Let me call to the Saad parents that he is not turning his camera and he's making it black. I don't know why he has chosen which camera. Is he has chosen. So many times I have listened to many different teachers that said that Saad never opens his camera properly. So let me talk to your father. And Aham, you also open.
Yes, sir.
Done. The question, the type of question that is going to come in your examination for this. Okay. So first of all, the type of question that is going to come, that they will give you first type of question in W by W percentage, that is also called mass by mass percentage. They will give you the mass of solute. Mass of solute will be given to you and mass of solvent. So when mass of solute plus mass of solvent is given to you, then mass of solution will become mass of solute plus mass of solvent plus mass of solute plus mass of solvent into 100. This question will become. If they give you, sometimes they give you mass by volume percentage, they need to ask, and they will give you the mass of solute and mass of solution. Both the mass will be given, and they will ask you to mass by volume percentage. So how can you convert mass of solution into volume of solution? So mass of solution, there is a relation between density and is equals to mass upon volume. So in the question where you've been given mass of solute and mass of solution, and then it will be given you density of solution also. Density of solution will also be given to you. And they can ask you W by V percentage, mass by volume percentage. Okay, let's do it. Yes. Okay, so mass by volume percentage. And in that case, that will be very simple that you have to do. Density is equals to mass upon volume. Okay, and this you need to understand. Got it? So you can do it very simply. Okay, so density is equals to means you can convert easily that you need volume, but you have mass, so volume will be equals to mass by density. So mass of solution upon density of solution. You have to do like this. Okay. So if you have a question on like you do this question. Do this question. Calculate the volume mass by volume when 25 ml of ethanol is dissolved in 100 ml of water? Do it. Do it fast. Do it. Note the question. Calculate the mass by volume percentage when 25 ml of ethanol, it is dissolved in 100 ml of water. It's very simple that you can do. Here is the solution also. That mass of solute is given to you. Mass by volume means then you need mass by volume. But here the mass of solute is not given. Volume of solution is given. So you have to convert volume into mass. And how will you convert? With the help of density. Density is equals to mass upon volume. So we have volume here, we have density here. You can do this by simple. 25 ml is volume of ethanol and density of ethanol is 0.8. Only just you need to keep in mind here that whenever you are calculating the mass by using density formula or anything, you have to keep in mind that the same thing will be there. Means if you need to calculate the mass of ethanol, mass of ethanol. So you are calculating the mass of ethanol. Na? So here should be mass of ethanol will be density is equals to mass upon volume. So volume into density will be equals to mass, volume into density. So you have to keep the volume here of ethanol and the density of ethanol, not the density of solution or the mass of solution density you take ethanol. If it is mass of ethanol, the volume should be of ethanol and density should be of ethanol. So it is being given to you the mass of ethanol is 25 and the density of ethanol is 0.8. Okay, so if you multiply this one, you will get 20. Is 0.8 is 200.0, that is 20. So you will get the mass will be 20 gram. Now what you need to calculate? You need to calculate the volume. sorry, mass by volume percentage. So you have total mass of solute is 20 gram and the volume of solution is 100 gram plus 25 ml. This is ml and this is also ml. ml will get added. Okay. And into 100. So you will get 20 into 125 into 100. You will get 4 and 5 you will cut. You will get 4. You will get 4 for the 16%. Understood? Understood? Yes or no? Everyone?
Yes, sir. Yes, sir.
So if you have not done the solution, please do the solution here. Yes. Go to this one. You have not done. Then we shall be moving to the next question.